will never see it coming. No warning, no countdown, no alert from any space agency on Earth. Just a night like any other. And then one point of light in the sky that isn't where it was yesterday. Pluto is out of its orbit, and it's aimed at Neptune. What follows is not a near miss, not a close call that gets studied in papers and forgotten in a decade. It's a full collision between two worlds, and by the time it's over, our solar system will never be the same again. Let's go through it honestly, without softening anything. Pluto is small, about 2,400 kilometers across, roughly the width of the United States. Rock and ice sitting out in the Kuiper Belt, nearly 6 billion kilometers from the sun. One trip around the sun takes 248 Earth years, longer than all of recorded human history. Neptune is a completely different animal. The eighth planet, about 49,000 kilometers in diameter. That's 21 Plutos lined up side by side. An ice giant wrapped in methane clouds that give it that deep blue color. The fastest winds in the solar system, over 2,000 kilometers per hour. 16 known moons, mass equal to 17 Earths. This is not a small target. Under normal circumstances, Pluto stays well away from Neptune. Their orbits do cross on paper, but they're synchronized so they never actually meet. For every 2 orbits Neptune completes, Pluto completes 3. That rhythm has held for billions of years. To break it, you need something serious. A large rogue object passing through the outer solar system. A brown dwarf, an undiscovered massive planet, gravitationally knocking Pluto off its path. Or slow accumulation of small perturbations from other Kuiper Belt objects eroding the resonance over millions of years, or something large simply hitting Pluto directly. It doesn't matter how. Say it happens. Pluto is heading for Neptune now. The clock is running. The chaos starts before any collision. When Pluto enters Neptune's gravitational sphere of influence, a region roughly 86 million kilometers across, it begins to accelerate. Its path curves. Neptune's moons feel the intruder's pull and start to lose their footing. Triton is the one to watch. Neptune's largest moon already travels a retrograde orbit that's slowly decaying. It will eventually break apart anyway in a few billion years. Pluto's approach could accelerate that enormously. Triton might get thrown out into open space, or dragged into a chaotic new orbit, or sent into an early death spiral toward Neptune. The entire moon system falls apart before Pluto even arrives. By the time of impact, Pluto is moving at somewhere between 20 and 30 kilometers per second relative to Neptune. A bullet from a high-powered rifle travels about 1 kilometer per second. Pluto hits at 20 to 30 times that speed. The kinetic energy released comes out to roughly 4 times 10 to the 30th power joules. The sun radiates about 3.8 times 10 to the 26th power joules every second. This collision dumps the equivalent of around 10,000 seconds of solar output all at once in a single moment. What happens next depends on the angle. A glancing blow, Pluto doesn't punch straight through. Neptune has no solid surface. Its atmosphere gradually thickens into dense, pressurized fluid with no hard floor anywhere below. Pluto starts coming apart in the upper atmosphere, shredded by ram pressure and friction long before reaching any interior. The ices, water, methane, nitrogen, vaporize instantly. A superheated shockwave expands outward. A column of gas and plutonium debris fires out into space, some of it fast enough to escape Neptune entirely. The impact also transfers angular momentum. Neptune currently rotates once every 16 hours. A hit like this could speed it up or slow it down and could shift the tilt of its axis. That tilt matters because it governs how Neptune's gravity acts on surrounding Kuiper Belt objects over long timescales. A tilted, destabilized Neptune starts nudging things differently, and some of those things eventually head inward. A direct hit, Pluto drives straight down into Neptune. The shockwave compresses the interior so violently that temperatures at the impact zone reach millions of degrees. Neptune's deep interior, that pressurized ocean of water and ammonia thousands of kilometers beneath the cloud tops, gets thrown into complete disorder. Under those conditions, diamond formation accelerates dramatically. Neptune's interior already produces diamonds through extreme pressure acting on carbon. The collision sends a diamond-generating shockwave through the planet that propagates for decades. At cloud level, a permanent storm larger than Earth tears open. Jupiter's Great Red Spot has been going for a few hundred years. The scar left by Pluto would take millions of years to close. Pluto itself is gone within seconds of deep entry. Tidal forces pull it apart, atmospheric pressure crushes it. Heat vaporizes whatever remains. The rock, the ice, the nitrogen planes, all of it becomes Neptune. There is no Pluto anymore. Karen complicates things. Pluto's largest moon is big enough relative to Pluto that astronomers sometimes call them a binary system rather than a planet and its moon, half Pluto's diameter, but still a substantial body. If the gravitational disruption is severe enough, Karen separates from Pluto before they reach Neptune. A freed Charon then either follows its own path into Neptune slightly later, flies off into a wild, eccentric orbit around the sun, or gets captured by Neptune's gravity and becomes a new moon, created entirely by catastrophe. If they're still bound together at impact, Karen arrives just after or simultaneously. A second strike. Smaller, but still carrying energy equivalent to billions of nuclear warheads. Neptune's magnetic field was already unusual before any of this, offset from the planet's center, tilted far from its rotation axis. If the impact disrupts the deep interior region where that field is generated, the field could weaken, flip, or grow even more disordered than it already was. Earth feels none of this immediately. We're billions of kilometers away. Light from the explosion reaches us in about 4 hours. Neptune, normally invisible without a telescope, briefly blazes in the night sky, possibly as bright as Venus at its peak. Then it fades, and on the surface of Earth, nothing else changes. Not yet. The physical consequences arrive on geological timescales. First, the debris. Enormous quantities of material ejected from Neptune's system spread across the outer solar system over thousands of years. Some fraction finds its way inward, redirected by Jupiter and Saturn. Over millions and hundreds of millions of years, the statistical chance of something hitting Earth increases, not dramatically, but measurably. More significant is the gravitational shift. Neptune and Uranus together keep the Kuiper Belt relatively orderly, shepherding millions of icy objects along predictable paths. If Neptune's orbit changes, even slightly, that shepherding changes too. Slowly, over millions of years, more Kuiper Belt objects destabilize. The flow of long-period comets into the inner solar system increases. More near-Earth objects, more impacts, gradual, geological scale deterioration of Earth's cosmic environment. There's a historical parallel worth noting. The late heavy bombardment, roughly 4 billion years ago, was a period of intense asteroid and comet impacts on the inner planets. Some models link it to gravitational instabilities involving Jupiter and Saturn shifting their orbits and disrupting the asteroid belt. What a Neptune collision produces is a smaller version of the same mechanism. Outer solar system instability propagating inward and raising the impact hazard for Earth over vast stretches of time. Then there's Triton itself. If it gets ejected from Neptune's system entirely, it becomes a rogue Kuiper Belt object on an unpredictable path. Triton is actually larger than Pluto, about 2,700 kilometers across, perturbed over millions of years by other bodies. It could eventually begin falling into the inner solar system. A comet the size of Triton passing near Earth would be an extinction event that makes the asteroid that killed the dinosaurs look minor by comparison. What this scenario keeps returning to is how precisely balanced our solar system actually is. The planets are where they are because they've spent 4.5 billion years negotiating gravitational compromises with each other. That balance isn't written into the laws of physics. It's the outcome of a very long settling process, and it could, in principle, be undone. When astronomers look at other planetary systems, they see the wreckage of collisions everywhere. Debris disks, planets with extreme axial tilts, systems missing planets that must have been ejected or destroyed long ago. Our solar system avoided all of that, or survived it early enough that the evidence has been largely erased. We got lucky, or we got time, which may amount to the same thing. Pluto hitting Neptune would be the most violent event in our solar system in billions of years. Pluto ceases to exist. Neptune is permanently altered. Its moon system is thrown into chaos. And the gravitational echoes of that single collision would still be shaping the environment around Earth hundreds of millions of years later. All of it starting with one small icy world nudged slightly off the path it had kept for 4.5 billion years, falling toward a planet it had always just barely missed. Until one day, it didn't.